So what's the one thing that keeps the entire internet from just collapsing under its own success? You've probably never even thought about it, but there's this hidden bouncer, this digital doorman called rate limiting. And today, we're going to pull back the curtain on this super important piece of digital crowd control. Let's get right into it.
Okay, so imagine this. You've built an amazing app. It goes viral. Millions of users are flooding in. I mean, this is the dream, right? This is what you've been working for. Well, what if I told you that overnight success could actually be your single biggest nightmare?
That's right. Welcome to Section 1, when success becomes chaos. Because without the right controls in place, that fire hose of traffic from going viral, it can turn your biggest win into a technical and financial disaster like almost instantly.
And this is what that chaos looks like in the real world. You've got malicious bots scraping every piece of data you have. You're getting slammed with DDoS attacks, just these tidal waves of fake traffic trying to knock you offline. Then come the brute force attacks, with bots hammering your login page, trying millions of passwords. And while all this is happening, your cloud bill is going through the roof. And the worst part? The actual legitimate customers you wanted, they get a slow, frustrating, totally unusable app. It's a disaster on every single front. So, how in the world do we stop this from happening? Well, that brings us to Section 2, controlling the flow. What we need is a bouncer for our application. You know, someone at the digital front door to manage the line and keep things from getting out of hand.
And our bouncer's name is rate limiting. At its core, it's just a mechanism that sets rules on how often someone or something can do an action in a specific amount of time. And let's be clear, this isn't about blocking people out. It's about making sure the system is fair, stable, and secure for everybody. But, how does our bouncer actually decide who gets in and when? Well, that's where the magic happens. Section 3, the algorithm toolkit. We're going to open up the toolbox and look at the 5 most common techniques for managing all this traffic.
First up, we've got the token bucket. And I absolutely love this analogy. Think of it like a coffee shop loyalty card for your API. You get a set number of stamps, or tokens, and you can use them all at once if you really want to. This is perfect for when you want to allow short bursts of activity.
So here's how it actually works. Picture a bucket that holds, say, 10 tokens. Every time you make a request, it costs 1 token. Now that bucket gets refilled, but at a slow and steady pace, maybe 1 new token every second. So if you use all 10 of your tokens at once, you've got to wait for a refill before you can make another request. Simple as that.
Now this is awesome because it lets you have those bursts. You could post 10 tweets in just a few seconds, no problem. But there's a catch. The downside is that an attacker can also use up all their tokens in one big burst. So it's a trade-off. You see this all the time with services like Twitter or Spotify, where they actually want to allow that kind of bursty user behavior. All right, let's move on to our next tool, the leaky bucket. Now, this one is pretty much the total opposite of the token bucket. This time, imagine pouring water or requests into a bucket that has a tiny hole in the bottom. It doesn't matter how fast you pour the water in. It only leaks out at one constant steady rate.
The huge plus here is predictability. Your servers get this perfectly smooth, manageable stream of traffic. But the downside? It absolutely, positively does not allow for bursts. A user can't send 10 requests at once. They all get lined up into queue and processed one by one, which, that can add a little bit of a delay or latency. This makes it perfect for things like payment processing, where consistency and stability are everything.
Okay, next up is the simplest of them all, the fixed window counter. The best way to think about this is like a gym membership that lets you visit 100 times per month. The system just keeps a running tally of your requests in a fixed time window, say 1 hour, and then at the top of the next hour, poof, the counter resets back to 0. Super simple, right?
Well, that simplicity, it's also its fatal flaw. And this slide shows it perfectly. Let's say your limit is 100 requests per hour. A savvy user can send all 100 of their requests right at 10:59 a.m. Then, 1 minute later at 11 a.m. sharp, the window resets and they can immediately blast you with another 100 requests. You just got hit with 200 requests in a matter of seconds, which could totally overwhelm your server and defeats the whole purpose of the limit.
So, to solve that problem, we have the sliding window log. This one is like a super meticulous teacher who writes down the exact timestamp of every single request that comes in. To check the limit, the system just counts how many of those timestamps fall within the last hour. It's perfectly 100% accurate.
And that perfect accuracy means it completely avoids that nasty flaw of the fixed window. So, what's the catch? Well, it is incredibly memory intensive. I mean, think about it. Storing a timestamp for every single request from every user, that takes up a ton of server memory, and it can get ridiculously expensive to run at a large scale. That's why you really only see this used for very critical, low-traffic systems.
So, if the fixed window is too simple and flawed, and the sliding log is way too expensive, what's the solution? Well, say hello to the sliding window counter. This is the really clever hybrid that, you guessed it, gives us the best of both worlds.
It manages to get really high accuracy without that massive memory cost. How? Well, it's kind of clever. It tracks the count in the current window, but also adds a weighted count from the previous window to estimate the rate more accurately. This makes it smooth, super efficient, and it doesn't have that big vulnerability. And that's why, honestly, it's generally the best all-around choice for most high-traffic production APIs out there today.
Okay, phew. Let's recap with a quick comparison table here. You can see all the trade-offs laid out pretty clearly. Notice how Token Bucket is really the only one that fully supports those big bursts of traffic. And Sliding Log gives you perfect accuracy, but look at that high memory cost. If you just need simple, steady stability, Leaky Bucket is your friend. But for that best all-around combo of performance, accuracy, and efficiency at scale, the sliding window counter is the clear winner for most use cases.
All right, so knowing the algorithms is one thing, but actually using them effectively, that's a whole other ballgame. That brings us to Section 4, Strategies in the Wild. Let's see how these tools are actually used to build real, robust systems.
One of the first big decisions you have to make is who exactly are you limiting? For users who are logged in, it's easy. You limit them by their user ID. For all that anonymous traffic, you have to use their IP address. And for other developers using your service, you limit them by their unique API key. Then you have to decide where this logic is going to live. It could be right inside your application's code, or at a separate layer like an API gateway, or for really big distributed apps, in a shared system like Redis.
Now, to bring this all together, let's look at what I'd call a masterclass in rate limiting, the Twitter playbook. These folks are absolute pros at applying all of these different techniques to create a stable platform that serves millions of people.
I mean, just look at how expertly they mix and match these algorithms. For posting tweets, they use a token bucket that lets you fire off a bunch of thoughts in a rapid burst. But for just reading your timeline, they use a sliding window counter for smooth, steady, predictable access. And then for search, they use that same powerful counter, but they apply different limits depending on who you are. Guests browsing the site are limited by their IP, while logged-in members get their own limit based on their user ID. It's just a fantastic, really smart, multi-layered strategy.
So if you take just one thing away from all of this today, please let it be this. Rate limiting is not a punishment. It is not about telling users no. It is a fundamental, absolutely crucial piece of architectural design that creates a better, more reliable experience for every single one of your users.
And that leaves us with one final big question to think about. We're entering a world where AI agents and automated scripts can make requests thousands, maybe millions of times faster than any human ever could. Our current definitions of fair use are about to be seriously tested. The future of rate limiting will be all about drawing a new line in the sand between human scale and machine scale interaction. Definitely something to keep an eye on. Thanks for watching.